Thank you very much. So why do we care about information spread in social media? We care about disinformation affect us. So there are campaigns that drive disinformation in online social media, and actually they have been used even by states, both internally and against other countries. And they did that in order to not only modify the perception of reality, but also to change political agenda and even to affect independent elections, and as a means of information warfare. But how can we define disinformation? Disinformation can be defined as information that is not true and that is made with the purpose to deceive. The definition seems quite clear, but actually there is a big debate in literature on its exact definition and on its classification. You might have heard the words disinformation, fake news, rumors, misinformation. Each of them actually has a slightly different meaning, and this makes it much more difficult to do research about it. It's also very challenging to recognize the true from false information automatically, and this makes the topic quite difficult. So malicious actors usually tend to take advantage of the fact that social media algorithms tend to prioritize popular content. And for this reason, they often pretend to be grassroots movement. What is a grassroots movement? A grassroots movement is a movement of people that spontaneously arise and is against or in support of something. And the term astroturfing comes from astroturf. That is the common brand of fake grass. So this gives you a visual idea of the meaning of grassroots and astroturfing. All right, so how can we detect malicious actors in online social media? Well, we can look at the behavior of single accounts, and this has been done. But recently in literature, there is a growing body of papers that have started looking into patterns of centralized coordination. Because if there is an astroturfing campaign, we expect a centrally coordinated information campaign going on. And the thing is, in coordination in online social media is wide spectrum of coordination. We go from unrelated users that are posting uncoordinated messages to grassroots to astroturfing, and in particular bots. The thing is, literature usually focuses on one end of this spectrum and does not consider the interaction between astroturfing and real users. So this is something that we want to address in the project. So regarding the approach, we are going to characterize a spread of information using network science. Why? Network science is an approach that's been used in different domains. And the reason why it's used is because, well, online social media, and in particular social systems or in general, are complex systems, meaning that their behavior does not only depend on the presence of their component of the system, but also from the interactions between them. And usually this type of systems can be represented as a graph or a network made of a set of nodes or vertices that corresponds to the component of a system, while the interactions between them are represented as edges or links. In doing so, we are focusing on the structure of a system, and this is valid for any complex system in general. So what we're doing is that we are disregarding any aspect of the nature of a component while we represent it as a network. And for this reason, we can apply the same set of methods in different disciplines, from biology to finance to social systems. This is an important network science measure. I'm going to mention this later on in the talk. And the degree of a node, for example, this node in orange here, corresponds to the number of links. But a graph can be weighted. And in this case, what is done is that you sum the weights of the links. And if the graph is directed, you can distinguish edges that go from the node, so links pointing out of a node, out the degree, or for the in degree, you look into links pointing to the node. But because you are disregarding the nature of the components in the representation, you can actually represent the same system with different graph representations. For example, if you have a social system, you have two individuals, this can be linked because they're colleagues, because they are friends, or because, for example, interact in the same social media. But even the nodes can represent different things. For example, you can look at single individuals, or you can group them based on some properties of a society, for example, and then one node would correspond to a group of individuals. So now let's focus on the social media space. If you have interactions between users in social media, can be in the same social system, but even in the same social network, for example, Twitter, you can look for the ties between users into retweets, mentions, quotes, or reply. And you can get different layers of information, even just in one social networks. Then the same author can be present in different social networks. So, for example, Twitter and Facebook. And you can look at the behavior of the author in different timeframes because the system is dynamical. And one day or the next day. And what about the content? You have information also in the posts that are a bit of a social media. So you can create another network using methods and approach from information theory. Now, you start getting the picture. We have different layers of information, and you can study each of them as a separate network, but you can also look at all of them together and look at with the multi-layer network perspective. Now, for the start of a project, of course, you have to start from somewhere. So we started characterizing one social media, Twitter, focusing on retweets for a specific time frame. As a case study, we decided to look into the Russia-Ukraine war. This is a war that started in 2014, but a year ago at the start of my PhD, basically. On the 24th of February, Russia invaded Ukraine. And we expect this information to play an important role as a means of information warfare. Why? Because at the start of a war, this happened. So this paper, for example, is a study on Twitter data of the data around 2014. And what they observed is that there's been a disinformation campaign that has been carried out by Russia. And also that reflexive control has been used in this campaign. Now, what is reflexive control? Reflexive control is a method for interfering with decision-making processes of the enemy. Basically, what you do is that to a partner or an opponent, or even a partner, you prepare some special information in order to change the course of his actions. And we expect this to play a role in this war. And especially at the beginning of invasion, for example, what happened in March is that Twitter banned over 100 accounts that push a specific hashtag, I stand with Putin. Now, not all accounts spread in these hashtags were taken down. And from that, with Bridget and Josh had the chance to collaborate with them. And based on their results, we published the results in a conference paper. And the analysis I'm going to show you is my analysis using instead network science methods based on the same data set. Okay, so what's the data set? The data set is all English Twitter content of any type. We have tweets, retweets, quotes, and reply. This comprises around 3,000 posts and 1,000 authors that publish them, that have been posted between one day before the invasion, the 23rd of February, to the beginning of March. And all the posts that we collected need to have at least one query hashtag that are I stand with Putin, I stand with Russia, or I support Russia, and that we label these query hashtags pro-Russia, or I stand with Ukraine, I stand with Zelensky and support Ukraine, and we label these hashtags pro-Ukraine query hashtags. Why? The thing is, this gives us the chance to study flow of information of two messages that are completely symmetrical and that happen at the same time, but they are opposed messages. So we have lower chances of biases. When we study, if we took instead another type of control data at a different time or for other type of messages, we would have higher chances of biases. Secondly, this is an interesting data set because Twitter suspended accounts that were pushing this hashtag, I stand with Putin. And then we have a focus on polarization. Instead of focusing on disinformation, on the definition of disinformation, and in particular, we need to label data as true information, true or false information, or rely on social media, recognize it's not turfing, we do not do any of this. So we remove these challenges. So what are the research questions? Well, first of all, we want to understand how polarized are the authors online. And are there different communities? Can we distinguish distinct communities? And if there are two distinct pro-Russia and pro-Ukraine community, is there a third community between them that merges and makes them talk? And then if we look into the communities that emerge, are there some structural differences in the network of interactions between the users? And these structural properties, are they related to astroturfing in some way? Do they give us indications of astroturfing? All right, so as a first step, we classify all the authors, we label them for the fraction of pro-Russia query hashtags they use. It means that we look into the pro-Russia query hashtags, we count them, and we divide by the total number of query hashtags they published. So if the fraction is 0, the author has posted only pro-Ukraine query hashtags. If it's 1, only pro-Russia query hashtags. And if it's between 0 and 1, posted both. Other thing, we are going to focus only on retweets. And this is because it's over 80% of the data are retweets. So we are looking at most of the data set. All right, so what's this retweet data set? It's retweets of original posts, meaning tweets, retweets, quotes, and reply, that have been published after the 23rd of February. So this choice is justified by the fact that most of the activity starts after Russia invaded Ukraine. So we cover all this, all the beginning of invasion and most of the activity. Interestingly, this plot shows the average number of query hashtags and authors in retweet data. The number of authors is of the same order of magnitude of the number of pro-Ukraine query hashtags over all the time. Pro-Russia activity happens on 2 days, when on the 2nd and 3rd of March, where it's comparable to the activity of pro-Ukraine query hashtags. But in these 2 days, the number of authors is not as much as affected by this increased pro-Russia activity. And we go later on this. So for the analysis, we focused on the first day of pro-Russia activity that has an activity comparable to the pro-Ukraine one. Okay, so with the 2nd of March retweet dataset, we built 2 retweet networks. One, they are weighted directed networks, where the nodes corresponds to the authors, and the links corresponds to are directed, and in the direction follows the flow information. So they go from an author of the original post to the author that retweeted it. For the weights, we choose to look into 2 different weights. One of them is the retweet velocity. This is a measure that we propose, and that corresponds to the sum over all retweets by B of A's original post of the inverse of retweet waiting times. Why? Well, the retweet waiting time corresponds to the number of seconds that has passed from the publication of the original post to the time it has been retweeted. So in doing so, we have a measure, the retweet velocity, that increases for shorter waiting times and increases for larger number of retweets. So it corresponds to the virality of the post, the virality of the post of the authors. And then we use the retweet count. The retweet count is the measure that usually is used in literature. And basically, these measures is important to consider both, because in this way we can compare the 2 networks and see what is the impact of retweet waiting time in the analysis. Just to say, from now on, I'm going to characterize the largest weakly connected component of a network, meaning it corresponds to most of the graph, 93% of the nodes. All right, this is a visualization of the retweet networks. And from this, we can see immediately that there are 2 very polarized communities. So the node size corresponds to the weighted degree, while the node color corresponds to the fraction of pro-Russia query hashtags. So the nodes that are blue post mainly pro-Ukraine query hashtags. The nodes that are red post mainly pro-Russia query hashtags. So we see a clear split into communities. And for this reason, we were able to use an event community detection algorithm that was able to label the author as pro-Russia or pro-Ukraine. This is a visualization, this time color depending on the community, and the algorithm worked really well. We are able to see that it was able to distinguish the 2 communities, and this is compared not only visually, but also with this plot of the number of nodes over the fraction of pro-Russia query hashtags. So we have 2 clear polarized communities. Interestingly, the number of edges between communities is very low. It's only 0.2% of the total. So these communities there isn't a third community that emerges between the 2. The distribution of retweet waiting time and the inverse gives us an indication, because the first question we want to ask is, the retweet waiting time, it's something that distinguishes the 2 communities? The answer is no, not really. There isn't a strong difference, but at the same time, we can also observe that both measures span several order of magnitudes for both communities. So there isn't a characteristic scale for this measure. But what about the network structure? What if you look into the network structure? Well, we observe strong differences. So we looked into in-degree, out-degree, and clustering. And these are complementary cumulative distribution functions of all these 3 measures in log-log scale. One thing that is important to remember here is that most authors retweet but are not retweeted, and this is going to affect the analysis. What we can observe is that even just looking at this is that there are different topologies in the communities, and there is a different behavior related to the retweet waiting time, and this does not depend only to the number of retweets, but I'm going to look at this closer. So let's start with the in degree. The in degree, let's look at the retweet count network. What we can observe is that there is a higher percentage of hubs, higher percentage of nodes that are hubs that have a really high in degree in the pro-Russia community. And at the same time, even the values, the nodes that have the largest in degree are in the Russia community. The in degree in this case, it means the number of retweets per author. So what's telling us is that even if there are less nodes in the Russia community, what's happening is that they retweet more than the pro-Ukraine community. And this is consistent with the plot that we observed before of the hourly number of authors and query hashtags. We then look into the weighted out degree. Now, let's look at the retweet velocity network. If you look here, the shape of the function is very different in the communities. In particular, there is a much faster decay in the pro-Russia community. At the same time, what does it mean? Well, let's remember that this means how many times or how fast an author is retweeted. This is a measure of virality. So this means that there is a lower virality than in the pro-Ukraine. If we look instead in the retweet count network, this difference of shape is not so evident. So what we can see here is this suggests the importance of retweet waiting time in the analysis of looking into them. We then started looking deeper into the in degree and the out degree, this time comparing for each node, its in degree and its out degree to see what was the relationship between them. So these are log-log plots. Every dot corresponds to a different node. On the X, we have the in degree, and on the Y, we have the out degree. Now, because this is a log-log plot, we are showing only nodes that retweet and are retweeted, because if the in degree out degree is 0, then they're not shown. And this corresponds to 2% of the graph, but it's very significant because it's the nodes, the authors that both retweet and are retweeted. If you look first in the pro-Ukraine community, there is a slightly higher out degree than in degree in both networks. So how can we explain this? Well, this is an hypothesis, but most authors retweet and are not retweeted. In degree means how much note of retweets, out degree means how much is retweeted. So these authors can increase the out degree of the other nodes, but of course they don't affect how much they retweet. So they can increase the out degree compared to their in degree. But what's interesting is when we look into the pro-Russia community, because here we have a much stronger behavior. Almost all nodes in the retweet velocity network have a higher in degree, out degree compared to the in degree. But in the retweet count network, we do not observe this shape at all. So what's happening? This means that they are retweeted faster, but not more often than the retweet. This is weird. We have also to remember that if you do not post anything original, for example, if you're a bot, then your out degree is 0. So this is really just an hypothesis that has to be confirmed, but this could be compatible with the presence of astroturfers that are retweeting posts of pro-Russia authors faster, but not more times than the authors of the posts. Maybe to increase the perception of virality. They don't really increase virality because we saw it before. The virality is still higher in the pro-Ukraine community. So here I just told you half of the story. There is actually another bunch of results in another topic, but for the interest of time, I'm just going to show you something out of curiosity to make you curious, so you can ask me questions. I have extra slides on this. But the thing is, we observe that there are two polarized and distinct communities. We observe that they have structural differences, but are these structural differences paired with different level of coordinations? Because for now, we didn't look at specifically coordination. And we did this looking at coordination networks. We built coordination networks, and in particular, built a system very similar to the other one with measures that are very much comparable to the previous ones, the co-retweet speed and count network. And just to make you curious, this is a visualization of the coordination network. And basically what we observe here, the main result is that there are definitely higher level of coordination in the pro-Russia community compared to the pro-Ukraine now. And this is even more striking if you compare with the visualization, if you're just looking at the flow of information of virality, that is a retweet network. Because most of the flow of information, most of virality, most nodes, edges are in the pro-Ukraine community. There is suspicious behavior in the Russia community. But if you look into coordination, the coordination is entirely dominated by pro-Russia. So, summarizing, we identified two polarized and distinct pro-Russia and pro-Ukraine communities. There are structural differences. We observe higher coordination in the pro-Russia community. This gives us indications of astroturfing. This is paired with a suspicious behavior related to the structure of the retweet network, because we observed some behavior that could be related to astroturfing. At the same time, from a methodological point of view, we proposed two measures. I didn't talk to you about the co-retweet speed. I didn't show you the results. But the thing is, we proposed the retweet velocity and co-retweet speed. And in the retweet network, we are able to see that the differences between communities are related not only to the number of retweets that usually is done in literature, but also the retweet waiting time. The second thing is that looking at the co-retweet network, meaning the coordination networks, we included in this measure, again, the number of co-retweets and these waiting times. We included the time measures, and this will allow us to study a whole range of coordination instead of focusing on one hand of the spectrum. There is no need to threshold. This is all what's usually done. You threshold for the number of times or for how short is the co-retweet waiting time. We don't do that. We do not need to threshold for two parameters. And we are currently characterizing the structural properties of these networks. So the next step is to study the second day of the pro-Russia activity, because we study only one day. This will give us means to compare with the previous day, see if there are differences, if something changes in time, and also to confirm our method. The second thing is to compare with the beginning of the pro-Ukraine activity. This is because we want to check for possible biases, if the beginning of a campaign actually affects the structural properties. But more in general, we already saw that just at looking at retweets for one type of social media, we're already seeing different layers of information that we can look not only as we've done until now for separately, but with a multi-layer network perspective. And we didn't even consider the rest. We are going to look into the time frame. More in general, what I want to do in the next is to look at the project in general, and more in general to the topic, with a multi-layer network approach, and to see if this is more effective for studying and predicting behavior in online social media. At the same time, I would like to create a model for information flow that is able to simulate, to predict, and possibly to contrast this information to understand how it works, how it affects real users, and more in general, how to contrast this information in online social network. Thank you.
Have we got any comments or questions?
I have a question about how Twitter works.
Mm-hmm.
If person A tweets and person B retweets, and if person C retweets, B's retweet, would you say that C is retweeting A or C is retweeting B?
It's A. That's a really good question. So that's what's happening here. So basically, it's always the original post. So that's why I stress the original post. So basically, this is also why the retweeting time is important. Because if you have a lot of retweets with shorter waiting times, it means that even if the chain was long of retweet, you are measuring the distance in time between the original post and the retweet, the last one, the one that you see. And this will count for the number of retweets because you will see B and C both.
Okay.
And in that, yeah.
So a short retweet time would imply that much of the retweets are coming directly to the original.
Not really, or it's so fast, it's viral, it spreads viral. And in this way, you will have really short retweet times. Yes.
In your results, like I think it was like the first network that you had there was like a blob that was like balanced.
Yes, I saw that. I want to look into it. Once this visualization was not easy to do, finally I got it right, because it's not, then you get all the results, but it's not easy to tailor in order to see things. But yes, this is interesting. And the other thing is that it's actually very much between the two. This is visual, this is qualitative, but it could be interesting to see who they are and if they actually made it. For example, this blue here, it's really much in the between, and indeed it was put in the other community.
My question was just like, with the rest of your results, if you remove those users or consider them as a separate group, like, does that have a big impact? Like, are they a particularly, are they an interesting group of users, or are they just behaving like the other version?
So if I isolate this,
Yeah, I was just sort of like a thought, maybe more so than a question. Because it just sort of, at the start of your presentation, you talked about how the AstroTurf might, it sort of seemed to me like you were indicating they might tweet both sorts of hashtags, sort of get in with both communities. And so like that might be like
yeah, the thing is, we need, for the statistical properties, we have to see this, first of all, how we pick them manually, because we see them, but in a visualization qualitative, and it's something that I split them in a mathematical way. All right, this is an algorithm, it might put this blob of nodes here or there, but still, the first thing is, how do we recognize them automatically? The second thing is, yes, but do we have enough nodes to actually look at the properties from a statistical point of view? Because we need 1,000 nodes at least that behave that way to see if they have different properties. Yeah, yeah.
Just a quick one, probably a bit of a naive one, but why do you call it the retweet velocity and not like a frequency or something? It doesn't seem to be any distance in your formula.
Yeah, so we kind of brainstormed a lot about the name. The idea is that there is a vector and there is an intensity. The direction is between A and B. There is a direction. Every time you have a retweet, you can sum the vectors. So you sum the intensities. So they behave like vectors. So that's why velocity. And speed, because it's undirected. So that's why. But we're looking for a better name. If you have suggestions, I'm up for it, because I cannot call it virality, because structural virality is something else in network science. So I cannot call that.
We like the integrate category directions, the coordination. So you need to have direction.
I need direction. Yeah. But if you have
suggestions. Well, I guess it was just one other one. Instead that you kind of came up with this formula yourself, right? The one over
Yeah.
GPT or whatever.
Yeah.
Tried other measures?
Yes, like several. But the thing is, so basically, I got more or less the same results. It was very similar, averaging in other ways, but pretty similar. So basically, at a certain point, if you calculate the log of a maximum, and you subtract by the log of a value, then this will give you a kind of a scale in the system. But of course, because there is a scale and there isn't much of a difference between the two communities, what's happening basically is that it becomes the retweet count network. And you do not observe any more differences. I tried a bunch of different things. This was the first one that came to mind, just because I wanted something. So the first one I tried is this, and worked. Then I said, is there something better? And I couldn't find anything better, or I found one that was scaling everything, but in this way it was just counting the Twitter, because it was squashing the differences and I wasn't able to see anything. Yeah.
I don't think there's any question. I think that's me in the chat. I've typed in the chat if anybody had any questions or comments that I don't think they have. So please join me in thanking Sara for a really lovely. And yeah.